So, welcome everybody. First off, I'm really sorry for that situation, but the research center I'm in has some internet trouble, so it's absolutely not possible to schedule a live lecture. So that's why we're going for this recorded format. I've changed the slides so that it's more like a podcast than an interactive lecture when I ask a question and you answer. So I hope it will be okay, and we'll use Friday's lecture to maybe catch up on the content of the lecture, and also feel free to use the MS Teams lecture channel to ask questions. There's something unclear, or if you want some clarification, and I'd be happy to answer you as soon as we have a decent internet connection. So today's topic, Monday morning topic, 8:30. Usually, is about type and interface, and that's what we're going to work on together today. So the whole content of this presentation is first to see what a type is and what does it mean to have a type and the relationship with offered services. Then we'll see what's called the Yagni situation, and if you don't know this acronym, that's something that will come a lot of time in the course, so we're going to go through it. And finally, we'll see what does it mean to give responsibilities and to think in terms of object-oriented design in the context of software development as, well, my object is offering a service, my object is doing something, instead of having my object is a bunch of attributes and some getters and setters, which is not really what encapsulation and information hiding means. So first, the notion of type as offered services. Well, we usually deal with classes, and suddenly out of the blue, I'm talking about type. So what does type mean? Well, basically, you can think of a type as an annotation, that's something in your source code that helps you to keep it coherent. Like a contract, actually, like a public interface. Like, if I agree to that type, if I am an object of that type, I offer this service. Like, I can add something to an ordered list. This is part of being member of the list type. And now if you go back to what a class is, a class, that's basically just a capsule that describes similar object. It's a factory to create objects that look alike, okay? And that can be conform to several types. Like an array list is conform to the type list. An array list, it's a concrete way of implementing an ordered collection of elements using an array-like representation. And this is absolutely compatible with the fact of being a list. So it offers the list type. How can you spot the difference in practice? Well, usually we use the types. It's not 100% true, but that would be a sufficient simplification. Think in terms of minimal variable product for 2AA4. There's more advanced cores that will dig into the details of what type theory and type system means. But in our case, we can just maybe simplify the situation by things that types are my signature or my declaration. When I'm saying that the get card thingy you've worked on with Sam last Friday returns a list of card, I have no idea what the actual implementation is. And in this case, the actual implementation, it's an array list, which is a concrete class. Okay, the classes are pink in this slide. And this is typed as a list. So I have no idea starting now that result is no more than a list. If it offers other services, I don't know. And actually, I don't care. There are some situations where the type, which is here a card, and the class are the very same, because each time you create a class, you're also creating a type. You're creating like a family of objects that will offer the services of that class. So sometimes there's a bijection, and card is actually the only way of creating instances of the card type. But that's not always the case. As you've seen, like an array list, it's conformed to the list type. So that basically for the scope of 2AA4 based on usage, okay? And then we can wonder, okay, but that's just no one really cares. I mean, this would work. Instead of using a list of cards, I can say that my results, when I'm exporting the cards from the card deck in Scout and Totem, it's an array list because, well, it's an array list. So I can use that type to declare my variable. Okay, that is legit, that compiled, and that actually works. But this course is not about software programming, it's about software development. So what we're going to look now is the implication, like the consequences of doing this in your code. So what you think you're doing when you're doing that is that, okay, you have the main class and it's connected to the notion of card, which itself is an object, because in Java, everything except the 4 primitive types are objects. And your main is using an array list. And an array list, it's an abstract list that is an abstract collection. Okay, so that looks pretty neat, actually. That looks on point. But actually, what you're doing is sort of completely different, because what you're saying is that you still have the main that is interacting with the card. That is true. I've removed the object to simplify the diagram. That's the very idea. But then you're coupled, you're linked to an array list. And an array list, it's an abstract list, which is an abstract collection, which is a collection, which is iterable, but it's also a list. It's also provide random access. It's also provide clonable capabilities and serialization capabilities. Okay, so by doing this, you're linking your code to a lot of features and services that you had no idea were provided by something else. Okay, you're just basically using the as down as possible element in the hierarchy, meaning that it's 100% concrete. And if you're reading an array list, you have access to all of those services. That being said, you could be like, okay, that's pretty cool, because for free, now that I'm using an array list, I have access to all of those services. That's awesome. Well, actually, that's not. And it's linked to a notion which is super important in software development, being coupling. So maybe you can like put the video in pause for a couple of minutes and think, what do you mean for you, for software, a piece of software to be coupled to another one? How would you define the very notion of coupling? Well, the official definition is relies on the number of assumptions. So you have a given class A and a given class B, and the coupling between A and B is defined by the number of assumptions that A made on B, knows on B, okay, the knowledge that you have on the other class. The more you know, the more you couple, because the more you're using, the more it will be complicated to kind of like extract you from the other. Which brings us to the very notion of Yagni, and it's kind of like relationship with software development. So before digging into what Yagni means, I want to like go more into details of what's happening here. Okay, and then we'll kind of like give you the definition of the acronym. So if we talk in terms of assumption, the assumption made by main, which is here, by simply using an array list, is that, well, first I'm using an array list, and the array list can have a random access. I'm not using it, but it can. And it's also serializable. Not using it, but it can. And it's clonable. Not using it, but it can. So I have those assumptions that I'm not using, but that are basically offered to me. So that's part of my definition of coupling. Okay, it's I have access to those information, so I'm coupled to those ones. And it happens that this array list is a list at some point, and that this list is a collection that I can iterate. Okay, and actually, based on the thing that you've done last time with Sam, we not need all of those. Okay, what we actually need is just the bottom. We need to know that we're interacting with a list and that this list is a collection that we can iterate. All the rest, we're actually not using it. You could say, okay, we're not using it, so actually we don't care. It's offered, but it's not consumed, so not really important. But what prevents you in like 10 days or so to suddenly said that, oh, I need this method and it's available, so I'm going to use it, and then introduce way more coupling into your system just because at some point you find something usable in random access and said, okay, let's use this one, instead of just thinking if there's a good way to do it, considering that your abstraction is not being a random access list. This is kind of like side effect. It's accidental that you have access to random access. What you really want to do is to have a list at the moment where you took the design decision of putting this into your system. So that's precisely why we have this Yagni situation. And by doing this, it's basically like we've coupled ourselves two things that we're not going to need. Okay, so Yagni means you aren't going to need it. And that's a very, very important design principle. If you don't need it, don't use it. Don't be coupled to it. Avoid being even exposed to it because you don't need it. The smaller, the better. It's very easy to define very complex piece of software, and it's super complicated to actually define simple software. Finding the right abstraction at the right level, binding those abstractions together, really, really complicated. And that's why this course exists, actually, to give you the tools to be able to do that. So Yagni, it's really about this. It's a design principle, can work at the code level when you're thinking about interfaces and type that offers method, but that also works when you're prioritizing your features in your MVP or in your backlog. If you don't need it, don't do it. Okay, this is I don't know if you're the Comics Monkey user, but they have very, very on point jokes in comics about software development. And that one is really a good illustration of Yagni. Like, you blew all the budget being this huge engine, the fastest engine possible, and then, well, you just can put a saddle on top of it instead of building the whole rocket because you're out of money and you can't do anything more. And you have some small tiny bugs in your engine too because you haven't had the opportunity to test it. So the smaller the better. Small is beautiful. Each time you design something, things in terms of engineering, you need to have something that you can master, you can control. And if it's way too big, way too complex, not under your control, then you will have no way to be sure that what you've done was done the right way. Okay, remember, build the right thing, build it right. Where in that case, build it right. We need to build it in a way that it's sustainable, that can evolve, and stuff like that. So if we take a look at the collection API in Java, that's just an excerpt because it's like way more complicated. But when you're doing this, like I'm typing my variable result with an array list, I'm basically coupling my main with this very array list, okay? Meaning that my decision is taken. It's written in stone that I will use an array list and I can use the add and I can use the get with a given index. Okay, maybe I'm not using it, and actually we're not using it, but still I have it in my code. But if you declare with a list, which is basically what we wanted, we're just coupled to the list and then the collection, and that's it. Of course, we are using an array list because that's a concrete implementation, the concrete class that we're using. But as soon as we instantiated it, this distinct decision disappear, and it's not our problem anymore. We're just living with a list, meaning that if I need to change my list to something else, I can. I still have a world of possibilities. Anything that is conform to the list interface offers a way to add an element. I can use it. Okay. So the kind of like, if I reformulate the notion of Yagni, is that you need a list, well, use a goddamn list. And there's no need to use something which is more specialized than what you need. And by coupling to lists, that's what I was saying, I have my list, which is now my result. I immediately forgot that the concrete array list, meaning that in my code, if suddenly my card deck needs to be a stack because it has the semantics of a stack, or need to be a linked list, or need to be a vector for any efficiency reason or whatever, I can do it for free. I just have to change the concrete objects that I am instantiating here. And the rest of the code only relies on the list, meaning that anything conform to the list type, the list interface, anything offering the method defined in the list interface can work. And that's correct. And that's fine. Okay. And we can go even further as we're only using the notion of add. Well, sorry, we're only using the notion of add. So we could have typed with collection. We're going to go like a little bit after in the presentation. So rule of thumb, each time you're instantiating a variable, you're declaring a type, an attribute or something, use the type, not the concrete class. Each time you manipulate a collection, think in terms of, is it a list, is it a set, is it something, not is it a hash set, is it an array list or those kind of things. Those are concrete details that you don't want to expose. By only exposing the interface, you're really supporting loose coupling because you can change your mind. You can suddenly decide, oh, it's not a list, it's a stack. Bam, just cost you one change somewhere and everything's fine. If not, you might have to change all the way down in your code where you were referring to an array list and now refer to a stack, which is a problem. So now that's my second point. That's what I was kind of like spoiling. I could have like bind myself to the notion of collection and not the notion of list. Because, well, I'm not really using the get method. Okay, I'm just using the add. So, okay, that's fine. But actually, a collection can be a list and can be a set. And if I'm staying at the collection level, it gives me both. I can still decide to move from an unordered and with no duplicate data structure, which is a set, or I can go to a list, which is a sequence of ordered elements with a partial order to exist among the elements. So by being too abstract, that gives me lots of possibilities, but maybe I'm losing semantics. And remember, the notion of type, it's an annotation that helps us to keep our code coherent and consistent. So if I'm saying that my result is a collection of cards, I'm removing the information that, oh, it's not any collection. It's a collection that is ordered and comes with this notion. Okay, it's a sequence. So to do that, considering this whole type hierarchy, the right one is the list. Going to array list would be way too restrictive. Going to collection will lose some information. So the one in the middle carries the right information. It's an ordered sequence, thus a list, and I don't care which precise kind of list it is, and I can change my mind if I decide to go for something else. So that's the very point. Be in control, know what you're working with, know why you're saying that this is a list or this is a collection, or maybe I explicitly need an array list here because I need all those interfaces, and that is perfect. But you need to be in control. You need not to declare variable and attributes and method signatures by accident, but you really need to be able to define and explain why is this used in your code at that moment. What are the pros and what are the cons of using this data structure, this type in the way you're developing. Remember, it's a software development course, so we're building on top of the software programming course. So we're basically advancing knowledge in this. It's not just about making it work. It's about making it work in the right way for the right person with the right product and the right feature. Okay, so kind of like pushing the boundary here. Finally, last part of the podcast will be about giving responsibilities. Okay, so in this case, we're going to go back to the Skoden Totem game, and we're going to look at what can we do with the card deck. So if we want to distribute cards to players, because that's what happened at the beginning of the game. If I need to draw n cards in a given deck, well, I need two functional services. Okay, I'm gonna like draw the card to the people. The first one I need to know is the deck empty? If you think in terms of your first assignment, that would be, am I dead? Have I rolled like 3 skulls? Can I continue? Should I do something? So that's a service. It's a functional feature that is offered. It's not a feature in terms of product. It's a service that is offered by the object that you're going to send a message to. Okay, so that could be, for example, asking to an object, "Are you empty?" And the object said, "Oh yeah, I'm empty." So you can't draw anything. Or it will be, "No, I'm not empty. So please be my guest. Go ahead, draw a card." And if I want to draw multiple cards, my first step, minimal and viable, would be to be able to draw one card. Because if I know how to draw one card, then I can iterate until the deck is not empty to basically getting the card one by one. So that can be my draw message. It's a void message, not taking any parameters, and it gives me a card. Okay. So I can, for example, draw cards from the outside, from the main, and said, "Oh, here is your card deck. Here is how many cards do I want. This is my result. My result is an array list. And well, until the end of the number of cards that I need to draw, if it's empty, it means that I've reached the end of the deck. So I should stop there. There's no more cards to draw. Sorry. And if not, well, I will basically pick them one by one, add them in the result, and return the result at the end, which is a list of cards. Okay. So that is kind of like a static implementation. I have an object pile. I can draw a card. It knows if it's empty or not. I can create a first version of my service, which is like draw multiple cards. First point, thinking in terms of business logic, make the code readable. Okay, I don't really need documentation to say that, oh, cp.isEmpty, well, cp is a card pile, so that should be related to the emptiness of the card. You can have like documentation helping you to certify and gives more information about this. I'm not saying that documentation is not important or recommended. I'm just saying that reading this code, I should be able to get the logic and understand the business logic without having to dig into the documentation. Okay, like if I need to go further, I can go into the documentation and get more information of precisely what the semantic of draw, for example. But just reading this, okay, it's like drawing card one by one until it's empty or until I'm done. But we've done that in the main. And actually, we had three different positions where we can put the draw multiple card service. Okay, it's what we call assigning responsibilities. Who is responsible for drawing multiple cards? So there are 3 points in our the system we're building. It can be the main, which is basically driving all the game. It can be the deck, so the card pile class. Well, it can be card, which is the card by itself. So just maybe put the video in pause for a couple of minutes and try to think like what would be the best way. Should be the main, should be the card pile, or should be like the card deck. Well, actually, none of them really works. The main, what we've done, not really helpful. It's part of the business logic, so it's not normal that the entry point, which is supposed to be static and supposed to be just like start the game, has to know how to draw multiple cards. That's pretty weird. That was the first one. The last one, the card, it just can't work by design. I mean, by construction, drawing multiple cards requires the fact that you're working on a collection. You're working on something that contains more than one. And a card, by itself, it's just a card. So it's just like, it can't work. So one reasonable candidate would be the card deck. Okay, you ask the deck, give me more card, give me n card, and that's okay. But if you want to keep the deck minimal, maybe giving it to the card pile might not make sense. So we can consider that would be okay, but maybe not 100% attainable. So what we can do is to introduce a new concept, a new abstraction in our card game, which would be a card drawer. Okay, and actually this can be abstracted pretty high because we have the notion of drawing stuff from a source, and I can draw from a card pile, but I can draw for anything that offers, are you empty? And can I draw one thingy? Okay, so I have this abstraction of source, which is basically, are you empty? And can I draw? And then I draw something. And if I have that, and I can make an assumption of something like the source, I can define a drawer of thing that will refer to the source and say that, oh, if I draw, well, I get a thing. And if I draw multiple things, then I get a list of things. Okay, so this is kind of my higher level abstraction. This is the reification of what I need to draw stuff from something. Then I can go to my game, and my game is like, oh, no, we're not any source, we're a card pile. And the card pile, it happened that it offers the method from the source. It has this isEmpty method, and it had this draw method. It had others, can be shuffled, can be blah, blah, blah. But from a drawing point of view, those are the only two that I need. I'm just coupled to the notion of source. And so my card drawer can be instantiated with the source of card, which is a card pile, because a card pile is a source of card, and then can implement how to draw and how to draw how many. And so my main will use the card drawer and will use the card pile. You see those different levels? We have the very, very high level where we define just the abstraction, the functional services that we do need to do our business logic. I draw thing from a source. And then I have my concrete level that is, oh, I'm not drawing anything. I'm drawing from a card pile using a card drawer. And then I have my game that is basically using the real objects, which is instance of card drawer and instance of card pile. You'll see that in this example, we have two different ways of representing our abstraction, our high-level abstraction. We have the drawer and we have the source. The source, we make no assumptions on it, okay? It can be anything. So it's basically an interface. It's something that offers is empty and draw. And if I know how to answer to is empty and I know how to answer to draw, I can be considered as a source. So you can really see this as a collection of services, okay? It's any object that is conform to the source type will offer is empty and draw. The abstract class helps me to define and reuse behavioral abstraction, okay? We've seen together that this draw how many can be 100% implemented with no assumption of what the source is. So I can actually write this code just by knowing that I'm talking to a source. I can describe, I can write the code, I can have these things up and running, okay? I can implement draw how many, and draw by delegating to source without having any information about the notion of source, okay, the concrete source that is used. That's why types, and that's why thinking in terms of behavioral abstraction is so important, because then it helps you to abstract what you need and to reuse as much as possible. So the implementation in terms of Java, in terms of UML, it's here where you have a huge difference between the notion of generalization, which is basically inherits in Java. So it's extension, it's extends, and the realization of an interface, which is basically an implementation. Okay, so the card pipe is an implementation of the source interface, and the card drawer inherits from drawer. Drawer is a generalization of card drawer. For those of you who knows Java like in details, we all know that now there's those interfaces that also contains default method that are kind of like blurring the line between interface and abstract classes. But in our case, we kind of like keep it by the book, and those are two different notions that can be blurry in some languages, but this is very Java specific. So that's why we're keeping it like separated in this course. And the question was asked during one of the last lecture, but when you're overriding something, it's a convention in UML to basically use the this little symbol to say that, oh, this is empty is not my creation. It comes from the realization of an interface. Which is important is that usually you use the generalization super bad because, well, you had an object-oriented programming course, you've understood that objects means inheritance and that you need to inherit from as many classes as possible to have a good design model. That is very wrong, and we're going to spend a lot of time deconstructing this idea together. It's actually 100% legit that you think this after the end of a Prog 101 course, whatever the Prog 101 course is. But that's something like using inheritance and realization, like generalization and realization, the right way, it's super complicated. So it's way more complicated than you think, and that's what we're going to do together, but later in the course. We'll actually take a couple of weeks before digging into the notion of inheritance. So we're going to do object-oriented programming without that many inheritance, which might sound weird, but it's 100% legit. Because when you generalize, you're really about a taxonomy. It's a structural classification, the species in biology, the different vegetable, like a cat is a mammal, a carrot is a vegetable, that this kind of representation that you're defining. And in our case, we're not in this is a situation, not often. We're just like, I'm offering this. I can be whatever I want. I'm offering this service. I'm offering this thing. And thus, we're relying on realization more than generalization, okay? It's the implements in Java. We're offering interfaces. It's a link between a specification and how it's implemented, how it's realized. A collection can be sorted, a deck can draw a card, you can draw a card out of a deck. Those kind of things, it's offering service. So that's realization. It's a dash instead of a plain one. And that means really, really different things. So when you're drawing a model, when you're implementing your code, don't use extends when you mean implements, and don't use implements when you mean extends. Okay, be in control, know your poison, know what you're doing, and be capable of explaining why you're doing that. If you look at those abstraction, how it can help, it's basically, I can move this, I guess. Yeah, let me put me here. So when you leverage the abstraction, you can represent things using like class diagram and sequence diagram, but you just have, I'm drawing stuff out of a source. I'm drawing a thing out of a source. So I'm offering draw and draw how many. Each time draw is called to a drawer, Well, we're basically delegating to the source, getting the result and returning the result. Why are we doing that? Well, basically for uniformity. It means that anytime you want to draw something, can be one card, can be multiple card, well, use the drawer, not talk directly to the source, so that you don't even know that there's a source. You just have your card drawer and you're basically giving the card to the people. Okay, so it gives you uniformity. And the more uniform is your design, the more simple your software development will be. Because when you look for something, bam, you know where to look. It's not like, oh, in this case, I need to look at that class, and in that case, I need to look at that other class. You have kind of like an entry point which carries the semantics of drawing stuff. And then if I want to draw how many cards, well, I can basically have a loop stating that, oh, for those many cards, if it's empty, well, I'm done. And if it's not empty, I'm drawing. And then I'm returning those. Okay. By doing this, we're really having this cohesive system. I've defined my abstraction, and this abstraction makes sense. Each time you want to draw something, find something that is a drawer, and that will give you the service that you do need. It's not like spread in the whole system. Oops. So to conclude, I can go back here. The takeaway message is really like, think of your code as object that offering services. It's not really classes. Classes are just a way to create the objects. Okay, it's just like the factory that gives you a way to use new to get object instances. But the instance is really a black box. I have no idea how it works. It's encapsulated. It hides information from me because honestly, I don't care. And I don't want to know the internal details. I need to draw cards. Well, give me a drawer and I will ask the drawer to draw cards for me. It's just like, it's not my responsibility to do it. And you will have the same with this idea of YAGMI. I'm not going to need it. So the more you couple to things you're not using, the less maintainable and the less evolvable is your code. So your coupling is defined as counting assumption. And the less you assume, the more flexible you are. The smaller, the better. Less is more in the context of software development. Okay, so we really need to be minimal in what you're designing, what you're implementing, and be sure that it makes sense to the end. Finally, in terms of giving responsibilities and non-responsibilities, it's a complex task, and that will be complicated. You will always wonder, where should it go? And that can be paralyzing. You can be like, oh, I'm fearing of doing something bad, so I'm doing nothing. That is the wrong approach. Embrace failure, fail early, fail quickly. Take a decision. If it's not the right one, you will be able to refactor. You'll be able to take your method and move it to another class. Oh, now I know that this is not the right place of doing it. But again, remember in terms of continuous improvement, to be able to move something to another place, it needs that first it was written, secondly it was used, and thirdly you realize that this is not the right place. So this requires time. This requires like a reflection, like this continuous improvement, like I'm doing something, it's not that good, I have a way to fix it, I fix it, Boy Scouts rule camp and a broken glass system, broken glass ID, find something weird, I fix it, and then I move to the next stuff. Okay? That will be all for me. Thank you very much for having watched this video. And again, that might be a little bit intense at the podcast. So feel free to send messages on MS Teams, and I will be happy to answer your question. See you guys.